Login accepted.
Thank you for coming. I don't see you, right? Because it's like it doesn't work this way. I will just use it for them. Because you read the description of the presentation. Yes? Not the title. Description. Okay. And you know that it's 2 hours. Okay. I cannot spend 2 hours with myself. So congratulations. You will have to spend 2 hours with me and with my toys. So my dear friend Kuba Marchwiecki, who is not here, he always saying that I'm king of useless presentations. And this presentation is a masterpiece of useless presentations. This is the biggest achievement of my collections of useless presentations. Because what I will show you is almost production ready in Java. Since Java 15, there are like experiments and tries to make it work. And I hope in Java 19 this will be like stable API. But probably none of you will ever use it. You will get all the benefits of these new APIs by using tools and libraries. But I hope you will be not directly using and importing these classes in your code, okay? That's why it's useless. Unless you write your own database, or you will try to rewrite Kafka. This will make sense to use these APIs, okay? So no funny things about JSONs, exposing things about HTTP over HTTP, because it will be really low-level Java. Okay? So you're staying here. Okay. Yes. So my name is Jarek, and I live here and work here. And yeah, for last 4 years, I waste my life and patience and everything and sanity as a staff engineer and team lead in the benchmarking team in Neo4j. And Neo4j is a graph database, the best one, of course, because this is our baby. The best database, graph database ever invented. So yeah, someday we'll take over Oracle. Someday. And I spent my last 20 years with JVM on different levels, coding different languages on JVM, including Kotlin, Scala, Groovy, Clojure for some time. And it was mostly with JVM. I spent some time being architect, and I regret it. I spent some time being manager, and I regret it even more. Because the only interesting thing in your work is code. And I'm also founder of conference, SecFold, which happens after vacation. Godfather of Programistyczna Grupa Rozwoju on Facebook, where we talk about the things you will hear here. And yeah, there is some new baby coming called JVM Club, a working title for people who want to know how the JVM works and talk about the internals. And we start next week on Tuesday with the first meeting. But you know, and I still have free time for a few couple other projects. So it's and I have 3 kids and 2 wives. Everything's okay. It happens from time to time, because I'm really like emotional person, that I talk about my own opinions. I know this is something that we are not used to these times, but I love my own opinions. And my own opinions are around sex, drugs, religion, and politics. It can happen that I will touch all of these topics in 1 sentence. That's fine. If you feel offended, that's even better, because you have something you care about in your life, okay? So there is no way you can cancel me, thanks to this slide, okay? Because you were warned. So here's the agenda, and the original version of this talk is 6 hours, because we are touching, in the original version, a little bit of more APIs that are coming. I will focus on 2 new. Actually, it's now 1, because it used to be 2 different APIs. Now, since version Java 17, it's one package and one API. Which version is on production in your currently running? 8, I guess. 11. Bleeding edge. That's good. So before, there will be a lot of code. There will be C code and Java code, and then C code and Java code back. I need to just give you some context why we need badly this kind of APIs in JVM, and why we get them so late. Mostly because they are like extremely complex things to implement in the JVM, Java Virtual Machine. So here is a little small taxonomy of languages, okay? So you have compiled languages, C, C++. Yeah, you compile them to the native code, you get the binary, you run it, you don't need anything else, everything is perfect, you talk directly with the hardware, and you need to take care about all the abstractions. The operating system, networking, is on you. Then you have a small group of languages which are compiled, but they contain a small bite of managed runtime. It's Go, it's Pony. So they are still compiled to native code, but they provide some kind of abstraction layer for memory management, file system operations, networking, and all of this kind of stuff. And at the end, I think we have the biggest and most popular category of languages, interpreted languages with managed runtime. So everything like JavaScript, Java, C++, Smalltalk, Lisp, Erlang, Python, so the things that are really popular compared to these languages are interpreted languages, mostly interpreted, because we know Java sometimes compiles code from time to time, if you don't write too big methods, but you do so. Why we need managed runtime? Have you ever thought about it? Because we want somebody to do the hard things. The things that are boring, we need to do them, because if we don't do them, we'll make hard ourselves. But they are hard. So memory management, acquiring, allocating memory, dereferencing, and allocated memory. Creating threads, it's not easy. In Java, it's too easy. I think creating in threads in Java is too easy. It should be much more complicated, so people don't use it. And don't make problems. So the threads. Code management. I think people say Java is successful because it has garbage collection. No. This is not a unique feature of Java. I think what is really interesting is that you can load code at runtime and even generate code at runtime, which Hibernate and Spring does. Yeah? And of course, calling native code, because we are interpreted, we sometimes need to talk with the operating system, and sometimes we need some kind of operating system abstraction. That's why we need managed runtime, to do all this stuff, because you don't think about it until some moment. So we need managed runtimes because we give a little bit of control and we get safety in exchange. So we say, okay, I don't control anything. I don't control the allocation. I don't control sockets. I don't control threads. The managed runtime does it, but you give me safety, okay? And there are 3 types of safety in my managed runtimes. There will be code, no worries. Memory safety, operation safety, and execution safety. The memory safety is you can read in C beyond the size of the array. You can? Yes, because you don't know the size of the array in C. In Java, you cannot, because you get array index out of bounds. In C, you can do operation like adding things on pointers or different types. No, you can add everything in C, almost. If you turn it into pointer, you can add it. In Java, you can do add operation on specific types. So this is the operation safety. Some operations are allowed for specific types. And then you have execution safety. So basically, you are able only to execute the code that you know it's your code. You loaded it. You don't get random pointer from somewhere and execute it. Okay? When you give up control, okay, you get safety, But what happens is you lose a lot of opportunities to optimize and make your code faster. Because somebody else manages things, So you cannot make things faster. That's why some people claim Java is slow, but this is bullshit. In general, Java as a system language, so C, Rust, is a stupid idea. Agree? Absolutely stupid idea. There are so many stupid people on the planet. Okay? Because if you look, Apache Kafka, Neo4j, Elasticsearch, Hazelcast, Cassandra, 90% of Apache big data ecosystem is Java. And these things require talking with disks, allocating memory. Why? No, this is stupid. You cannot control it, and you write things in the worst possible language for this task. Are these people stupid? Or, I know a couple of them, they're not. Because in case of database system, I think safety is more important than performance. Because you don't want your database to randomly crash. It can be slow, but if you crash, you usually lose data. Yeah? So you don't want your system to crash. You need safety. Safety in terms not the security, but safety in terms of execution. If you want something to execute, it will happen, it won't crash, okay? But we still need speed. Really need speed. So what happened? Years ago, some engineers came up with this idea that actually Java needs speed. So we will create something called sun-misc unsafe. And this is like a backdoor to your sleeping room. Okay? You don't want random people coming into your sleeping room. So this is a set of unsupported, undocumented methods to talk with your operating system. So you can allocate memory outside of heap. So this is where the garbage collection doesn't do anything. It's on you to allocate and free. You can check the object layout. So basically see if the field is at this address and the field in this object is at this address. So you can read directly fields from memory. There are some low-level concurrency things like atomic operations, volatile operations, and so on, and support for serialization. And it was unsupported, undocumented, never ever fucking use it, this API. Internal use only, okay? What happened? We are so clever as developers. Why not? Okay? So all the systems you use today, including Spring, they are using this unsafe API. Because why not? And when Java 9 started, there was this idea, okay, we will take away unsafe, because this is unsafe. Java is about safety. So we will take away unsafe. There was like huge scream from community around. Don't take it from us, don't leave it, we need it. We make money on unsafe. You wouldn't have Kafka without unsafe. So what happened at the time when Java 9 was coming, Oracle said, okay, we'll keep unsafe, but over time we'll provide APIs, stable APIs, that will substitute all of these different things, and you will have to migrate to new API, and at some point, like 2085, 2086, they will close, and the unsafe still will be there, but it will be not accessible for us. That's the plan, okay? So I will show you the part of this plan, and I will show you these two, okay? The object layout and memory allocation, and of course the foreign functions interface. So yeah, if we would have 6 hours, we will talk also about vectorization, frozen arrays, primitive objects, and low-level concurrency controls, but Grzegorz, for some reason, said 6 hours is too long. I don't know. Okay, let's start from allocation. In Java, you can do new, and this object will be on heap. Wake up. Yes? So it means that at some point of time, the lovely garbage collector will come and will clean this object. Everything is happy. You don't have to worry. You don't have to write destructors. Beautiful. But sometimes you need access to the native memory, so-called off-heap, sometimes C-heap, sometimes off-heap, sometimes native. It's all the same, okay? Different free names for the same thing. You need it, for example, if you have like 1 terabyte of data, and you need to load it into your memory. If you load it to the heap, what will happen? The garbage collector will die, okay? Probably the garbage collection times will dominate your application time. You will spend more time garbage collecting these things, because even if you keep this memory, the garbage collection will need to go through the heap during the reachability analysis inspect 1 terabyte of memory and decide, okay, there is nothing to free, but I wasted 1 second to check that there is nothing to free. So in case of our case, like Neo4j, we have something called page cache. So we keep some part of the data in heap, but indexes, the database content, we keep off heap. It's the same pattern for Hazelcast, the same pattern for Elasticsearch. Nothing was invented here. And in Java 7 or 5, I don't remember, they came up with this idea, okay, we'll give you direct by buffer. Okay, and the direct by buffer will keep a pointer. Remember these things from the university? Pointer. One more time. Pointer. And it will keep pointer to the memory. And when the Java objects will be freed by the garbage collection, there is some nice tricky mechanism I will show you. It will call free, deallocate the memory, deallocate this pointer. Okay, the memory the pointer points to. Okay? The problem was that this implementation was really cool, and it's used, for example, by Netty. In some cases, if you configure Netty, it will use direct by buffers. If you don't configure, it will use its own implementation of it because it's faster. But the problem with it is insufficient under pressure. So when there is a lot of direct by buffers, the garbage collector wouldn't keep up with freeing the memory, and we will end up with out of memory, but not heap, but the JVM crash. Thank you. So there is still a way to do it using unsafe allocate memory. The problem with it is breaks guarantees. It's on you, it's your problem. If it breaks, you're screwed. You don't call Oracle support if you have support paid licenses. And if this is not official API, it can change, go away, whatever. And if you are crazy, you can use Java native interface and write your own call to malloc. Yeah, that's me, 15 years ago. I thought it was a good idea. So what happened? In Java 14, they came up with this Java enhancement proposal that will propose new stable API to work with direct memory. It took them 1, 2, 3, 4, 5 versions to come up to the final API. So all these changes are like in the incubator mode. So they are not enabled by default if you use JVM. You need to pass special flag to JVM to enable and then start using it. And in the beginning, there were 2 APIs, one to allocate memory and the other one to call C. Because this is when it comes fancy. And around Java 17, they said, okay, the foreign functions and foreign memory, they're so close together and depend on each other. They said, okay, we'll make one specification. And then they will cover the foreign memory and foreign functions. And in Java 18, they did some improvements in API, removed methods, added new. I will focus on this one because I realized we have Java 18 like 15 minutes ago. And I love risk, but there are limits. So all the examples will be on Java 17. Okay? At the end, after 2 hours, some examples will be on Java 19 early access build, but it will be like super bleeding edge. Because Java 19 has something extra, cherry. Have you ever read Java enhancement proposal, this document? You know how it's structured? There are stand-ups, backlog grooming, interesting things in work. Okay, sorry. Do we have Scrum Masters? Hopefully not. So every Java enhancement proposal has a section called goals. It has also a section called non-goals. And in the goals section, it describes, okay, if we do it, what will happen? What will change in JVM, okay? And in non-goals section, it's like, we are not covering these things in this. This will be different API. And let's talk about the native memory goals. The first thing is they want to have a single API to work with different kinds of memory, not only native. So there will be single API to work with native memory, persistent memory, managed heap, so the good old heap memory, and also memory map files. So anything that is memory related will be accessible from the same API, okay? So at the end, you will not see the difference between segment of memory from native code, from native space, and segment of memory from the heap space, okay? Or memory map file or persistent memory, whatever. So one API to work with memory. The second thing is safety. So they promise, we give you access to native memory, we give you pointers in Java, and we get pointers in Java now. You will see. But we'll still try as much as we can to make it safe. So we give you razor, but with like, nice plastic wrapping to not cut yourself, okay? Still have razor. The control, so basically it says, okay, if you allocate memory, you will choose how you deallocate it. And you will make like a decision when the memory will be free and returned back to the operating system, okay? Yeah. And usability, so as you can see, we want to make our API so sexy. They use the word compelling because they are from US. But it's like so sexy that we won't use unsafe anymore, okay? So the new API will be so interesting and good that people will abandon unsafe. The funny thing, this API will use unsafe, but it will just wrap it under hood. The motivation, why we do it. So basically, we have a programs that will benefit from the access to native memory, and it includes Ignite. I don't know why they use this as example. MapDB, super example. Do you know MapDB? No, but good example. Memcached, Lucene, we know it, and Netty. Okay, so Netty will be even faster with this one. I don't know. You need to ask Norman. So why? You want to avoid the cost of garbage collection. Yeah, that's one. You want to share memory between multiple processes. So now if you have two Java processes on the same machine, if you want to talk between these processes, you need to have some networking, yeah? Over local host or Unix domain sockets. Now you will be able to create memory segment and share it between two Java processes. Serverless, cold start, should work, yeah? Caching things. And of course, to make serialization and deserialization to files faster. Okay, that's the promise. So if it's use case, if you have any of these use cases in your projects, you are probably in the right company. Okay, memory access. Now we switch to console. And I might need my glasses. Where I have my console. Too many screens. So how you get a native memory in Java? How you get a pointer in Java? So the way it works, at the moment is in this package, Incubator foreign. It will be in Java foreign at some point of time. So now it's in this one. And like the entry point to all of this is memory segment, okay? So memory segment is a kind of a pointer, okay? And you say, I want to have memory segment of native memory, let's say 8 bytes, just for sake of 8? Yeah, let's do it 8. And now about safety. What it means, you want to be able, like to delegate to virtual machine that when you don't need this memory, the JVM will free it. You wouldn't need to remember about it, okay? So they have something called resource scope. We use global scope. What it means, I create a memory segment, and as long as this resource scope is live, available, reachable, whatever you call it, keep this memory segment in memory. Okay, it's fine. But when this one will be garbage collected, then all the memory segments created in this scope will be freed. Okay? The resource scope is auto-closable. So you can do it in try, resource scope, auto-closable, and when you exit from the try block, everything will be fine. Okay? There is a special scope called global. It means it's never cleaned up. Welcome back, memory leaks in Java. Okay? Haven't seen you for a long time. So once you do it, you will get, let's do it like this. Okay? So we have now memory segment, and if we take this one, we'll get a pointer to this memory segment. Okay? Everything is good. What we can also see is the byte size. Yeah? So it's 8 bytes. We can check if it's native. Cool. Okay. You can also do something different. And you want to say, I want to allocate a memory segment over the array. So let's say come on. Okay, what's the difference? This is on heap. That's why you don't need global scope. Because this is on heap, you destroy, you lose reference to the memory segment, garbage collection, everything is cool. But you get the same API. So it means you will be able to do this, byte size, okay? But if you call is native, it's not native because it's on heap, okay? Clear? Clear. So let's make another example. Let's say that we want to create a scope for our memory. So there are a couple of types of scopes. Let's start with confined scope. Source scope. Oh, it's not confined. Oh, it's confined. Okay. So there are a couple of types of scopes. There is global scope, confined, implicit, and shared. Why? Let's do, okay, memory segment, allocate native 8 bytes in the confined scope. So we are not giving the global, we are giving the confined scope. Okay? And then we do something like this. We create new thread, and in this new thread we will try to, I don't know, whatever. Okay? So we'll try to access this memory in a new thread. We wouldn't see the exception. That's better. Yeah, it will be hidden really bad. Can we do this one? No. Okay. What will happen if you use you need to trust me. If you use not the first time. If you use confined scope, you are not allowed to pass this segment to another thread. You are able to only read and write to this memory segment from this specific thread. Okay? no sharing. And if we say on our confined scope close, okay, and we take our object, how I can check it? Oh, it's still alive. Then we need to wait for the garbage collector. So basically, if we call close, we are now will be freeing this memory segment. But we need to for the garbage collector to do its job, okay? And of course, we have the shared scope. So this is where we create things in the shared scope. The memory segments can be shared between different threads. And we have implicit scope. It means you are not allowed to close it. So if we try to close implicit scope, it will throw exception, okay? So this is the kind of global scope. But you can create our own global scopes, okay? Clear? So it would be good now to read and write from this memory, okay? This operation is called dereferencing in the spec, and it's a little bit confusing. So let's create memory segment native. Yeah. Okay. So how to access this memory? The easiest way, there are helpers in the memory access class. And in the memory access class, you can, for example, do set int on our memory segments, and we want to set 256, okay? So this is how we set the value of memory. And of course, we have the get operation. And we get the value, okay? So, and we are able to read bytes, longs, ints, floats, doubles, whatever, okay? Simple? It's not, because it's a little bit more complex. What they came up is memory handles. Have you heard about var handles? I'm so sorry. So var handles was Java 11, Andrzej, or something like this. So there was this concept that they said, okay, at some point of time we will need pointers. We don't need them now, but 5 years before they thought, oh, maybe that will be useful, and they introduced something called var handles. So you can think about var handles as pointers to values. Okay, it can be anything. It can be field. It can be a value in an array. Anything you come up with. And there will be one API to work with different kinds of handles. So the memory access is a util class, but what it does, it's something more nasty. You call var handle, and then now starts the magic. Byte order. I need to import something. Order, and we get our memory handles, var handle, int class, byte order, whatever. Who cares for this example? What it says, give me a handle, some kind of pointer to a value somewhere, okay? And this value will have something called carrier type. So carrier type says, okay, I have something in native memory. I don't know what it is. It's a sequence of bytes. But I want you, dear Java, to convert the sequence of bytes to this type, okay? So at the moment, all primitive types can be carrier types. There's one exception called memory address, which can be also a carrier type. But we'll come to this. So now you say, okay, I need something to operate on a value in memory, and I want to represent it as int. Okay? So we have memory handle. And memory handle has this. Yeah. So you need to give it a memory segment, an offset, do you feel what happened? Pointer arithmetics. So it took our memory segment, this one, and it said, okay, take this memory segment, take offset 0, and read int from this offset 0. Okay? So what we have at offset 4, 0, because we allocated 8 in these 4 bytes. Right? Yeah, I think still probably nothing has changed. So we just set the other half. Okay? So if we go to our memory access and we say add offset, and we say 4, and we say different value. Let's say it's my favorite number. Okay. And we do this. Okay. Clear? You are now able, so as you can see on memory segment, you have two things. You have base and offset, always. The base is a pointer and offset is how far from the beginning. So now with the var handles, you can take, where's my handle? You can take anything and read it from, and set and get whatever. The thing that is, yeah, this will be interesting. So method handles always need 2 coordinates. The memory address, so the memory segment, and offset. In case of set, you need third value, the value you want to set. So this is like the parameters for the set and get operations. What's super sexy is, do I remember how to do it? Handles. No, not this one. We can go to handle, to method handle, and we want to say, okay, handle to method handle, and we want access mode. Let's see it. Method meh handle. Okay. Meh. What are method handles? It's the same concept as var handles. It's like small stubs that allows you to invoke a method, any method. Okay? Without it, without method handles, you wouldn't have your lovely streams and lambdas, because this is the part of this whole magic. Okay? And the method, so var handle is a variable, and method handle is a method. Okay? And now I say, I have a memory handle, and please give me a method that will allow me to get things from this. Okay? Cannot find symbol. What? Oh, not read. This is this. Yeah, this is wrong. Sorry. Wrong access mode. Too many class in invoke var handle. access mode. Now it will be okay. And I want to have var handle and it should be now get. No? What I'm doing wrong? Oh, yeah. Okay. We get a method to get things from the memory segment. Okay? And as you can see, the signature of this method is I take as a first argument memory segment, as a second argument our long, so offset, and I return int. Now the magic part. Because method handles have something called combinators. Okay. What I say is like, you know, I have a method which takes memory segment and takes offset and returns int, but can you modify this method in runtime and change the signature a little bit? I want to invoke this method in a different way. And there are many different combinators. They are called method combinators. One is called bind to, okay? Do you see the difference? Now, the signature is I take offset and I return int. There is no memory segment. Because what I did, I created new method, and the new method is a delegate which replaces the first argument with this value. The first argument in the method with this value. So now, if you want to access my mech, I just need to give it a offset. Because thanks to bind, it created a delegate method. This is lovely. Okay. And this one still works. Why it's so sexy? Because, for example, you want to protect reading from memory. And you don't want to allow somebody, the client of your library, to read any region. You can bind the offset. It's not only first method. You can do many different things with the method combinators. And say, I give you a method handle that can read and write only this part of this huge native memory. Total control over it. Okay? What's even better, for all the Java concurrency freaks, and I see a few faces here, I can do compare and set. Okay? I can do atomic operations on native memory. I can do volatile reads and writes on native memory. Smiling. Yes. I can do volatile set, volatile get, acquire, and set release. All the low-level Java memory things I can do on native memory, thanks to one API. This is what I call architecture. Okay? But 5 years before, you think about what you will do in 5 years, and you introduce method handles and var handles, and they say, okay, and now everything magically happens. Cool, isn't it? So we have resource, scope, we know how it works, and we have memory segment, we know how it works, and we have memory address. Kind of we know how it works because there are like few hidden gems about memory address, but we'll come to it later. And now comes the fun part. Because we can now read and write native memory, nothing, absolutely nothing, only our imagination stops us from reading and writing C struct, C union, and C objects. Nothing, okay? So they came up with this idea called memory layout. What is memory layout? It's basically a description of what's in the memory. So you say, I have 120 kilobytes, and the first 4 bytes is int, the second 4 bytes is pointer to string, and the third byte is age, the regular business boring stuff. So you can describe these things in Java, and start accessing things that were created in C libraries from Java. Example. Say, do you remember structs from C? Yeah. So let's say we have a struct, and this struct have Java int. Okay. And maybe we'll have a second field, which will be, oh, it's maybe tricky. Yeah, let's do Java, for example, layouts. Java, come on, double, and name, money. That's only what counts in life, age and money. So now I have a description of a structure. And the first field is name, and it has the size, 32 bits. And the second field has name money, and the size is 64 bits. What it means is basically, I need some fancy editor to do this. Oh, whatever. Plain text. It was double, yeah. Okay. So basically, memory layouts allow you to say, okay, I have object in C, object, a struct or union, and I can say, okay, Java, please, now if you read access this native memory, this is the layout of it. Yeah, whereas the first field is age, the second field is money, and we have a nice description how to access it. Is it helpful? I would say yes. Come on. Go our method handle. Access. Get. One more time. I need to take an example. I don't remember it. Yeah, it will be better this way. Yeah. Can you see it? Or I can, yeah, we'll do it differently. Take memory layout, var handle, super helpful. The carrier type, how it's called, memory layout, okay, path element. Layout, path element, group element, name. Oh, I did long or units of name use age, sorry. So what it says, give me a handle now to this specific field. And you don't have to remember that offset of this field is 4 bytes, 60 bytes or something, because you can specify, just take from this layout, find the field age, okay, and create me handle to this field. What's funny is it supports nesting. Because if we, for example, will have a structure like this, and enter presentation mode, and we'll have something okay. We can, okay? So how we will access this? In our case, we'll take the address, and in address, we'll take the memory layout, path element, group element, and it was street, yes? So now we get a handle to an element of struct in struct. So it supports nesting. And because this is handle, you can do everything with these handles. So for example, you can give your customer, your library customer, because sooner or later everybody will become library developers. The AI will write codes. I hope so. You can give your client of your library, but you can access only and modify only the street field. Thanks to var handles and all of this magic of binding parameters. Okay? I will show you even more examples later when we go to fancy demo, because there's at the end is a fancy demo that was created around 12 hours ago. But it's fancy. It includes images, moving images. So stay. Stay with me. What you can do with the memory layouts, this one, not this one, layout. As you can see, you can create sequences, so arrays, to map our C arrays to Java arrays. You can create structs to map something to something. You can create unions, and you can also add padding. Because sometimes layout of your object requires padding. We will come to this one. So you can do anything. End of memory. Now we go to the funny part. Even more funnier, C. I will come back to memory at some point because there is one thing I didn't tell you, but I think it will be more obvious and clear when we start to look at functions. Questions? What when? It works. Wait for my demo. It's on Java 17 stable, and it works. And it imports some fancy library, I wouldn't tell you, and does some fancy stuff between Java and C. You can start using it already. You can do whatever you want. But remember, with great power comes headache.
So this kind of stuff is already used by all the companies you mentioned, Kafka, etc.
I don't know about Kafka. I know that our team is experimenting with it. We have, until now, we had our custom JNI code written in Rust to do it. Secret. There's a little bit of Rust in our database. But I think sooner or later, once it becomes stable, because it's like in the JDK incubator package, I think we'll shift to it.
Because the final goal of such things is take the control and gain the performance.
Yes.
And the trade-off is a little bit of safety.
Mm-hmm. I explained it. Yeah.
What happens if we try to read to be custom?
Exception. This is safety. So every memory segment has temporal scope and spatial scope. So it means how long it lives and how big it is. So you cannot read. That's the part of the safety. You cannot read beyond what you allocated. Okay? Boring, 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 boring. Boring, boring, boring. Sorry. I thought, how's time? Yeah, that's fine. Okay. We'll come back to unsafe memory access because there are cases about unsafe memory access. But we'll come back to this, safety, blah, 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 blah. Accessing C. Okay. What options we had? We have right now. It's JNI, Java Native Interface. Old, like me, gray, bold, fat, disgusting. Okay? Disgusting piece of handwritten by some students probably on last minute, like, they released Java 1.1, it was like, we need Java Native Interface. We have 5 minutes, okay, let's do something. This code looks like this, exactly. And what's funny, it's used internally by your file sockets. Now, when you use files, when you use sockets, it calls JNI, okay? And it's ugly. So that's why the community created a lot of wrappers around it. Java Native Access, Java Native Runtime, Java CPP, JNI Easy. I think the last one is commercial to work with JNI. Have you ever used the native keyword in Java? That's why you are smiling all the time. Just to show you how stupid this process was to call C code from Java, what you had to do in the past? You need class, because everything in Java is class. And you need something like this. Okay? So this was the first. I'm not talking about the future, I'm not talking about the past. So you had to do this, and then you had to call magical tool called Java H. And this magical tool, Java H, was generating a C header file. So now you had to go to this C header file and fill out the implementation. But your implementation had to be aware that you are running in managed runtime, that you have garbage collector, that you cannot access memory, that if you get something from Java, the address can change because the garbage collector will reallocate the object, and you have address to the wrong place, okay? And then you had to compile this library, then load it using system.load library, and maybe if you had luck and did a sacrifice from your kids, it worked, okay? So they want to change it. To make not only our, but their lives easier. What's the state of this project? At the moment, the assumption is that when they release the stable version, they will only support x64, so no support for 32 bits architectures, and it will only support Intel and ARM. This is basically what we care, mostly, unless you are running Java on a mainframe. It will support only C. So you will be, in the beginning, able to work only with C libraries. So anything written in C++, Fortran, whatever else, Rust, Go, will not work. This is MVP. The plan is that once the MVP, huge success, we'll implement the remaining languages. Why? Because C++ is extremely difficult. You have classes. And the name of the method in class is what? Some random generated. There's a process called name mangling. So you change the name of the C++ method to something random. And magic, yeah? So that's why this is the MVP of this effort. how it works. And of course, in the future, support different architectures and support different languages. So there's one entry point called C-linker, which links your code, Java code, with C code. Okay, this is your entry point. And the C-linker basically has two methods that are interesting for you: down calls and up calls. So down calls is a situation when from Java you want to call C code. So you have nice library with some machine learning algorithms optimized, blah blah, image rendering, whatever, and you want to call it from Java to the C. Okay? Obvious, interesting. But there is a second case, up call. You want to call Java from C. Why? This is the example that spent me like the most time to find a good use case for this. I will show it. But basically, with C-linker, you can give a C code address of Java method, and C code will be able to call Java method. Yeah? I will show you. We'll come to it. It's a little bit surprise. Okay, so let's start with the first simple example. What's the get? Yeah, get bit example. I choose the simplest possible C method that will make it, any effort, any wow factor. So basically, you have something called. So there is a C method in the standard C library in every operating system, excluding Windows, but we are talking about operating systems, which allows you to get process ID of your current running process. Yeah? And it's called getPit, and it has really simple signature. It takes nothing and returns pit_t, which is actually alias to int. Simple. So, what are the steps? And remember about this whole magic: native, compiling, Java Age, generating files. The assumption is that everything will happen in Java, and Java developer, I love these guys, Java developer wouldn't have to think about C, and generally shouldn't think too much. So everything will happen in Java. First, you need something called symbol lookup, and this is like a handle to all libraries in your system. Everything you loaded, everything you have on your library path is accessible from it. And you get a symbol, and symbol is basically method. So I say here, give me the linker, and please, linker, please find in all the libraries I have this method, getPit. It returns the optional of memory address, okay? So what you get is a pointer to C function. This is memory address. So we have our method. Somehow we need to now tell Java that, this method takes void, so nothing, and returns int. And tell Java how to map C types to Java types. So that's why we need two things. The function descriptor, this one, gentlemen, which says, okay, I have a method that returns cint. Do you see the difference? There's a Java int and there's cint. So C-linker has all the versions of primitive types for C, and memory layout has all the types for layouts for Java types. So we have a method that returns int and don't have any parameters. And then we say, hey, and I have a method in Java which returns Java int. So I have a function descriptor, and I have method type, and I have symbol. And then comes the magic. Whoopsie. Down call handle. It says return a method handle for this symbol, and please, that's why it's method handle. Once again, reuse something that I invented 5 years ago. And adapt this type to this type. So this will be changed somehow magically into this signature, because there are two different signatures, okay? You get the method handle. And what you do is just invoke, okay? Should I try? Trust me. Okay. It's my computer. Woo! What happened? It said illegal native access. So, hey, lovely, they don't trust us. I think Brian Getz doesn't trust us at all. They say, you know, Java developer, cool, but you want to call Java the C method. But actually, what we give you here is unsafe memory address. So there's a special case of memory addresses which are unsafe. What does it mean? They were not created by you. These are the memory addresses to something somewhere. It may happen that somebody will call free and you wouldn't know about it. And you will hold pointer to something, okay? So they say, okay, it's illegal. How we can call it? And what is the name of this one? Okay. So we need extra magical switch. And we need to say, I give you the permissions to do it because I trust you. JVM. Okay. So you say all the accesses to unsafe memory addresses are allowed only from this module. So you make in your configuration conscious decision, hey, I know I trust developer of this module, we tested it, we have test for it. How does it sound? We know what we are doing. We haven't drank too much during the development, and we know, we trust this module, okay? And this module can access unsafe addresses, okay? So addresses that were not created by the memory segment methods. Okay? There is a PID of this process. You have to trust me, this is not random generated number. It's the PID of this process. So it means you can call any C method you would imagine. As long as you know how the structures looks like and you can create memory layouts, I mean describe all these things and know how the things look like, the signatures of the method, and how to convert the C to Java, everything is fine, okay? And what this thing does, you remember the carrier types? There is one extra carrier type, which is not primitive type, and it's called memory address. And if you have pointer, you just use memory address as a carrier type for the pointer. Okay. That's all, folks. Yeah, just joking. There's a lot of more. Okay. So now, stupid example about calling Java code from C. Okay? I was really thinking for a long time how to do it. So basically, this is for all the cases where in C code you need some kind of handler. Like you have a function that gets a higher order function and you want to call this higher order function from C code. Yeah? One example is signal. So this is a special system call in a standard library But you can say if you send specific signal to your process, like kill, term, whatever process you send, invoke this function. Okay? So if I say kill minus 15 number of my process, it will invoke this function. And this function is C function. But in our case, we want to pass it here, Java function. We want, when we send kill minus 15 to our process, we want to execute Java code. Are you with me? Okay. How it works? A little bit more code to do it. The usual things, we get the system lookup, we get the C-linker, and first we need to, there's a problem, a small, tiny problem, because we have Java method, and the simplest possible solution would be to just send a pointer to this Java method. There are 3 problems. One problem is there is a garbage collector. And during the meta space cleanups, it can change the location of this method. So if you give an address and address changes in the meantime, you will be calling God knows why. What? Yeah, system exit. I don't know. Some random stuff. So that's one problem. The second problem, in Java, your method can be in 4 flavors. It can be interpreted, it can be compiled with C1 compiler, it can be compiled with C2 compiler. Things happen. And they can exist at the same time. So you want to point to this Java method, whatever happens with it. So you need something called stop. So the thing is, nice trick, how to solve all the IT problems? Add one more pointer in direction. Because they create a pointer which keeps pointer. And when garbage collector changes the location of the method, it just updates the pointer in pointer. Thanks to this, we have one stable address, and then the whole Java mechanism is just making sure that this pointer in this pointer points to the current version of your method. Lovely. Yeah? So what we say is like, okay, I need a handle to a Java method, static method, called onSignal in this class, okay? And the signature of this method is I take int and return nothing, okay? And this is our method. So this is our handle to this method. Now we need to change this handle into stop. So we say, okay, create me app called stop, so this pointer to pointer, which is memory address, so pointer, for this method handle. And this is the usual stuff, the description, how to convert one into another. There is a resource scope, okay? So it means, because this is a memory address, it has a time to live. You want to, for example, sometimes free it. So you need resource scope. So now we have an address to stop. All good. So what we need to do in next step, install the handler. So call the method signal. So we say, okay, get me the signal method from the standard library, and there will be a little conversion. This method returns void, takes int, so the number of the signal you want to respond to, and memory address, and map it to something that takes cint and cpointer. So memory address and cpointer are like the carrier types and interchangeable, okay? And we are installing it, and it should work. I hope so. Probably, maybe, we'll see. Yeah, what do I want to do? So I want to run this one. Okay, it won't work because I need to copy paste stuff from here to here. It's the same. It's the same module, but everything is fine. And you can run it. Okay. So what happened is this is the address of the stub in native memory. This is the signature of the method. And we are waiting for signal. So let's send some signal. We need to find a bit of this process. How it was called? Sig term, yes. Yeah. So we have our process. Bing. And what we did, I think we installed signal 15. Okay. Will it work? Oh, do you see? I'm sending from C signal to Java process. Bam, 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 bam. Wait for demo. Yeah. So this is basically what we can do. This is the state. Java 17 works. And the truth is that I thought that I have an hour for this presentation, but I realized I have 2 yesterday in the evening. So I said, okay, there are 2 things I can do. One thing is talk slowly to you, or do some fancy demo. Okay? And I actually have 2. The last one I'm afraid of. And the first one is, yeah, kind of proud of it, because, yeah. Let's switch to the demo. Why we are here? Why we work as software developers? If you tell money, it's just fame, money, fun. Okay, thank you. I was counting on somebody saying fun. Yeah? What is fun in writing REST services? Nothing. I'm here because I wanted to write games. Okay? My first computer, this is like really personal, between me and 30 people. And camera. It's really personal. My first computer was Atari 800 XL, extra large. 64 kilobytes, 320 on 200 pixels. And yeah, my younger brother was way better in games than me. He was killing me in every single game. And I'm older brother. And it's my duty to be better than him. Yeah? So I decided I will write a game, but I will be better in. And I wrote my first game using ASCII art because I didn't know how to get into graphics mode. And it was a clone of Space Invaders in ASCII art, in BASIC. So yeah, we are because everybody wants to write Witcher. Yeah. Nobody talks about fancy Neo4j. Everybody talks about Cyberpunk. And I waited for it 20 years to be able to start running games in Java. Because what you can do, what's hard in games? The thing that is hard in games is hardware, talking with hardware. And if we have something that already talks with hardware and it's good at it, some kind of game engine, library, framework, then you can have the game logic in Java. Yeah? Why not? There are lots of games, for example, which use Lua as a language, or Python. And they just have fancy C++, C, high-performance things to render stuff. Why not Java? Yeah? So I said, because I still believe, maybe around when I be 60, I will write my own game. I still believe that I can do it. From time to time, I play with library called SDL, Simple Direct Library. So this is kind of like DirectX, but works on different platforms. It works on Linux, and works on Mac, it works on Android, lots of different platforms. So I said I will write you a little game in Java using libsdl, okay? If you want, if you are interested, so if you go here, a simple direct layer. And there are commercial games written in this one. This is open source. This is not game engine, so it doesn't have like logic of handling sprites, collisions, physics, and this all fancy things. It's all about playing sounds, catching input from mouse, and drawing stuff on screen. So let's have fun. Oh, I'm so excited. This is the first time I'm showing it. Like a kid. So what I had to do, I had to somehow map all the C functions in this SDL library to Java code, okay? And I will show you step by step what happened. So because SDL is not like on default library path, so it's not loaded when you start JVM, you need to like manually load it. So you basically say system load library SDL2, and there is a library for handling images with different formats like JPEGs, PNGs, and everything. So I'm loading these two things in the beginning, yeah, because I need. Otherwise, the system lookup, the simple lookup, will not know where to look for symbols. And the first step, yeah, I think I will show you step by step here. The way it works is, first you need to create an init function. Call init function to initialize the SDL library. So if we take a look here, where's my lovely? We have SDL init, Java method. What it does, I have a method handle for the SDL init method in this library. This method returns int, like every good C method returns int, just to check errors, and takes int, which says which subsystems to initialize. Do you want video? Do you want audio? Do you want joystick? Do you want keyboard, mouse? So you can like enable, disable different subsystems. So I said, okay, I will need video and keyboard is enabled by default. So I say, I have this method, and I want to invoke it. This is like copy-pasted from the header file. Yeah? So this value, you need to go to the header file, and now you should feel the pain. If you have a huge library, you will have to rewrite this header file manually to Java. Unless you use Java 19, but it's the last demo, okay? And yeah, what I do, I check if the error is different than 0. I say, okay, this is this library error. Take the error message from the SDL. This is as well SDL get error C method. But it's really simple because it returns a pointer to a string, okay? And I convert it to a string, and as you can see, there are helper methods. Convert address to Java string. If you know that this is C string, you can call to Java string, whereas the opposite operation, convert Java string to C string. Okay. Works. So next step, I want to create a window, okay, on the screen. I don't want to full screen. I want to have window because I want to debug it and see what happens. And this window has a title, game. This is the position of the window. Basically, if you say 0, 0, it means like centered. And then this is the width and height of the window, so 800, 600. So this is our window. And again, if we go here, we need all this magic, yeah? So create, and this is a little bit more complicated because we have function that returns memory address, takes the memory address, and then, okay, a list of ints. There's one thing that you need to convert Java nulls to C nulls, okay? And it's quite easy. I think so. Where it is? Okay, I will show you in different example. I will show you how to convert Java nulls to C nulls. This is not this example. So we get a window. From window, we need to get something called surface. And surface is basically a canvas, like in the JavaScript canvas. So something you can put points, colors, and that's all. So we get a surface. As you can see, for every SDL type, I have like a twin type in Java. So I'm wrapping, and if you look at, for example, this one, the SDL window keeps an address to this C structure, okay? And then when I call methods, I will just pass it. I start to pretend that C is object-oriented language. Okay? Pretend. Then I need pixel format to know if this is 24-bit screen or 16-bit screen. And I can get it. But then comes the problem. I need to manually, I'm not drinking and I'm not yet taking hard drugs. You have to manually, on left side of the screen, open the C file, on the right Java, and then rewrite the structure. And of course, you need to be aware about this fancy thing, padding. Because this is 64-bit, and this is 32, and this is 64, so you need to have extra 32 bits to have memory alignment. Okay? You need to start thinking about CPUs at this point. It will be better in Java 19, promise, show you. So I had to map a lot of structures with it. And now, okay, every game needs a sprite. Yeah? A sprite is this moving thing on the screen. It can be whatever. Yeah? It can be throwing flame ball, fireball. It can be eggs. It can be person walking. It's a sprite. And every sprite is a collection of sequences, so animations. Okay? So there is it's called craft pics, and there is a lot of ready-to-use images, icons, moving small little tanks and people and trolls and backgrounds. So you can create your own game using, you don't have to be an artist because we are developers. We are artists, but still. So I have 3 sprites. One is a gentleman walking. The other sprite is, the sequence, the animation is the gentleman executing the attack. And the third one is like doing nothing, idle. Yeah, when there is no input from keyboard, it's 2D platform game. Okay, and I need to create a rectangle, which says, okay, this is the position, initial position and size of my sprite. Okay, and SDL rect, as you can see, is also but really simple layout. It's 4 ints, position and size. So I have my sprite, okay? My sprite with sequence, different sequences, and the initial position. Okay. And of course, I have here a logic, okay? Walk forward, so what we do, what kind of animation we show when we are walking, what we are doing when we are attacking, what kind of animation we are showing when we are doing attack, and of course, what happens when we are idle. It looks like business code already. Attacking, walking. And of course, there are two important functions. One is update. So we say walk and we update the state of the object. This is like in 2D games, platform games, everything was invented. So there are even books about 2D game patterns, you know, like we have in singletons and stuff. The sprite and sprite sequence is quite popular pattern. And then we say, okay, we update the position and the frame based on the previous actions, and then we draw it. Yeah, we have simple draw method. The bleed scaled, as you can see, this is lovely, again, method handle to C code. And I think, yeah. So basically, you need to do this. If you have Java null, you need to convert it to memory address.null, because Java null and C null are different things. Yeah. Basically, this null is a segment of offset 0 and 0. This is null. Okay, so we have our lovely creature. We need now to move it. So we create event, okay? And this was crazy. This was the hardest part. Because event in SDL is huge union of different types of event. But because what can be event? Keyboard, mouse, touchpad, time, whatever. So they have one huge union that emulates all types of events. And how huge it is? Okay. So it starts here. And this, I know my life is miserable. Okay. So what, as you can see, every type of event has always type and timestamp. This is how we implement inheritance in C. So the same first fields, time and timestamp, and then the remaining fields are different. Okay. This was crazy. Yeah, that's good. We will have time for last demo. And then comes the great game loop. Games are really simple. In like the whole concept is simple. You take events from the queue, mouse movements, clicks, keyboards. Then you pass all these events to all your sprites, saying, okay, this happened. You know, you pressed this, something happened. Then you update, then you say, okay, everybody received the event. Then you say, update the state. Okay? So we say, okay, that I'm walking, I'm attacking, I'm doing something. And you update the state, and then you draw it. Then you wait, because you want to have this frame rate of 30 frames per second. So you wait the time, and you show the next frame. Okay. This is how it works. You take the event, you check the event type, and based on event type, if I click right arrow, I will walk forward. If I click space, I will attack. And if I stop walking, so I key up and key down, if I stop walking, I will go to the idle mode, okay? And then update. Do you want to play my game? This will be hit, so smashing hit. Please work, please. If it will not work, I will quit programming. Whew, let's go. Works. And it's quality production code. You can write a game engine. I mean, game engine, and then on top of game engine, you can write games in Java. Of course, there are lots of edge cases, like memory management, because if I load image, it creates the SDL surface object. And because this is memory address from native memory, you need to take care. This is not the global scope now. The scope will not help you, because you haven't created this using the scope. So you have to manage on your own. There is a nice trick you can use called cleaner. And this game even quits. If I click. Oh, I'm so proud. Yeah, I should now call the project red and say, hey, let's rewrite Cyberpunk in Java. Maybe this time it will work. One thing is, because you have memory address from native, it means you will have to call free on it. But you can delegate this to Java, thanks to this simple trick. If you have, this one. If you have this one, where I call cleaner, give me a second. And then, okay. Yeah, it's here. So Java has cleaner. Enlarge? Yes, of course. What is cleaner? It's in Java lang ref package, and it's how to call it? A hook into garbage collector. Okay, you can say using a cleaner, whenever you garbage collect this. Yeah, I spend too much time with computers. I need to remind myself to stand up, roll my eyes. So in cleaner you can say, whenever garbage collector cleans this object, execute this action. So you can register some kind of listener on garbage collector. So if you have this case that we have surface, and surface has memory address, so whenever we garbage collect this one, we want to free this one, yes? So what we say to cleaner, hey, if this one dies, please execute this function. So there are lots of different problems. It's a lot of time, things you need to think about, like error checking and different programming styles. Yeah. As you can see, there is lots of ceremony. Still, it's simple, but there is lots, huge amount of ceremony. Unless Java 19 comes. Because what happens is they said, okay, we have now this lovely mechanism. Maybe we can auto-generate Java code based on header files. So as you see, this code is really repeatable. It's really like, I have struct, I need to create the struct layout. I have union, I need to create union layout. I need to map the same fields to the same fields, take ints to cints, and so on. So in Java 19, there's a tool called JExtract. Yeah. So we have Java 19. How it works? You give it a C header file. Okay. Let's take, for example, the main one, and we'll say generate a C code based on this header file. As you can see, not all cases are yet supported. Not all type conversions are supported. Not all function signatures are supported. Like, for example, long double. I don't know what it is. Okay. But it doesn't fail. That's really good. So it gives you all the C structures generated by machine. it's not only the layout, but also all the methods and handles. Everything. So I have last demo for you. Yeah, that's good timing. Unusual on my presentations. I said, okay, let's see how good it is and try one more crazy example. There is something in operating system called POSIX queues. So this is a way to communicate, to enable communication between two processes. One process can send queues, things over the queue to another process. It's not Kafka, it's not RabbitMQ, this is like in-memory queue supported by the operating system. So I say, okay, let's talk with Java and C over the POSIX queues. Why not? Code first or demo first? Code first. So this time, I did not generate, write handwritten the conversion. I generated using the JExtract. So basically, this is it. I create a queue called /queue, really creative. And I create queue attributes what says, okay, I can have maximum number of messages in this queue, maximum size of the message will be this. And I create these things, okay, are from here, from the generated code. Okay. So what I do here, I create new queue, and it will be read-write queue, and if it doesn't exist, create. This will be the file permission because the POSIX queue is a file because everything is a file. And I say, okay, once I have the POSIX queue, I start to listen. Yeah, I give it a buffer to put the message in this buffer, and I need to allocate this buffer in the native memory because Java wouldn't work with buffer in the heap memory because you know what happens on heap already. And I receive the message and just print out the content of the message on console. Okay. Whew. This exploded before the presentation, so bear with me. Let me check. Java 19, enable, load, should be fine. We are waiting on POSIX queue for messages from somewhere. Okay. So I have a library, a tool to work with POSIX queues. It's called MQ. And it's Java code. As you can see, make files and all this crap. So this is a small utility to send, receive, and check status of queues, the POSIX queues. So let's say, okay, let's see if our queue exists. Because, the POSIX queue, Java says POSIX queue is opened. Let's see. Yeah, there is POSIX queue opened. It has maximum of 10 messages. Maximum size of the message is 8 kilobytes, and there are no messages in the queue at the moment. So I can do is a send message from C, oopsie, over standard library. Okay. And this was like almost zero effort, yeah, because I just run JExtract. I can show it, how it looks in my build system. So in POM, I have an extra step that calls JExtract. Okay. There's no JExtract plugin yet because this is 19 early access. No, who cares? So I call JExtract on the POSIX library. So this is the header file for the POSIX library. I generate source files in the directory and then start using it. That's all. Ooh. Questions? At this moment, it's at the same speed as Java native interface. The goal is to make it faster, but at the moment, if you think about it, it's just simple jump and execution. The trick is about the parameter conversion. That can be tricky, but the overhead is comparable to JNI. The plan is to make it even faster. In the meantime, that's my little secret. I have none. Basically, I think this approach that you have a Java class that holds the address, it's a good approach, because the problem what I had is like I have memory address. What it is? I don't know. Yeah. So it's really good because now you change something that where you don't have type safety. Thanks to this, you have type safety. So if the only moment where you don't know what it is when you create it. But once you wrap it in your Java objects, when you pass it, you know it's the surface or window or something. There is one thing that may be interesting, and I haven't used it, is like the layouts can have attributes. So you can do some kind of runtime checking. But if you are passing something with wrong attribute and that attribute will be like type, you can fail. It feels like better approach than creating Java objects. Why? Because you, again, go to garbage collector. Again, you use garbage collector. So you have the same thing twice, in Java and in C. So it may be for a lot of objects, like you have zillions of pictures, you will need to have zillions of SDL surface that just are simple wrappers around the memory address. There is a solution for this problem. It's called Valhalla. Yeah, 2030 something. Once we will be able to allocate things on stack, because they look like records. It's like final, lots of final fields. Yeah, it should be final. So yeah, if you don't use Java types or attributes, you're just asking for segfaults everywhere. Mm-hmm. No, because I haven't shown you. There is concept of memory map files in operating system. So basically, you can open a file which is mapped to memory. Okay? So because this is file, it can be shared. And because we can, if I go back here, will it remember my imports or no? Oh, great. Import. Yeah, problems. Segment. App file. So then you pretend that you are sharing through file, but this is not what happens. So you can have then as many. I think the Java Chronicle, this library works this way, but it uses its like own hacks because it's like pretty old. Thank you for coming, really. Have a good day.